Hey guys, what is going on? It is your good buddy Sam, and I don't know what to tell you, but this tutorial is going to represent a radical departure from tradition. And when I say that, I mean that this one is actually going to contain useful information. And in fact, I'm going to show you some stuff in this tutorial that you might not be able to find literally anywhere on the web. And I say this not because I'm imparting any kind of genius here, but because I showed the videos that we've done recently to Rob R., the guy at Cycling74 who does all the OpenGL stuff, and he sent me back some really, really, really smart suggestions that are going to make this thing just like a million times better. So I want to dive right in because I'm not going to lie to you, it's a little bit complicated, but we're going to get through it. Or at least that's, I mean, really I'm talking to myself here. It's difficult for me even to keep all this in my head. So hopefully we'll make it through okay. We'll see what happens. So anyway, I'm starting by duplicating multicube 4, which was the last iteration of this project that we worked on. I'm renaming it multicube 5. And now opening up that multicube max project, and it looks, wait for it, like this. So you remember this guy was making a bunch of cubes, and nope, didn't quite work just yet. Let's give it a second to get itself ready. Take your time. Not like time is money or... Okay, this is interesting in that it's barely working. Let's see, does this need to be on? Yes. There we go, okay. So the cubes are moving from place to place, and that's really exciting. So what we're going to do, the problem that a lot of people pointed out, that they're quite right to point out, is that inside this poly tilde, we've got a JIT-GL material and a JIT-GL grid shape for every single one of these shapes. And in general, that's really bad form. You want to use a JIT-GL multiple to represent multiple shapes, because that's going to draw much, much faster, much, much more efficiently, and let you draw a bunch more shapes, which, I mean, obviously more shapes means better art. You know, if you can be expressive with one cube, then of course you could be 100 times more expressive with 100 cubes. That's just, you know, that's just art. This is how it works. The problem is that it's this JIT anim drive. We need this JIT anim drive to be connected to some kind of GL entity in order to work. And I thought this meant that JIT.anim.drive had to be connected to a JIT.gl.grid shape. In fact, it doesn't. We can use a brilliant trick. We can connect the JIT anim drive to a JIT anim node, which just represents a sort of abstract OpenGL you know, Holy Ghost type entity, and then we can use that node to update the position, the individual cell, the matrix cell, that's going to tell our JIT-GL grid shapes where to be in the context of a JIT-GL multiple. Does that sound crazy? That's because it is, and only the adamantine mind of Rob Ramirez could have conceived of it. But now we're going to see if we can't be the cubic zirconium to his polished ruby. That was a remarkably salient metaphor, even for me. Anyway, so let's do it. So here's the crux of where everything's going to happen inside the actual poly itself. I'm going to start all this stuff. Really just moves the cubes to a random position. You bang on this noise, it spills out some stuff, blah, 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 moves the cubes randomly. I'm going to cut it. I'm going to paste it back here in the patch so we don't forget about it. But that doesn't need to be, we don't need one of these random position makers inside each and every instance of this polycube thing. We also don't need a different material for each cube. That's just wasteful. We don't even need a grid shape. That's just wasteful. So we're not left with much here, right? Not a great deal left. That's okay. Let's begin at the beginning. This JIT anim drive needs to know the graphics context we're talking about. So I'm going to give it an @draw2 #1. And this way, this JIT anim drive will be able to reference an OpenGL context that we pass as an argument to JIT to poly tilde. This isn't going to be in 4 anymore. This is going to be in 2. I want the second inlet to talk to JIT anim drive. And I want the first inlet to just be open for now. Okay. Now, the key part of this is that what we're actually going to multiply is not the grid shape itself, but the drivers and the nodes. We want each cell in this matrix to be a node. So I'm going to call this jit.anim.node. And you can think of jit.anim node as basically a disabled grid shape in some sense, because what it does is just represent a rotation or position and position in GL space without any actual drawing attached to it. So what we're going to do is animate the position rotation transformation, and apply that to each cell in our JIT GL multiple. So we connect the drive up to the jit.anim node like so, and now the drive will animate the node. This in one here is just going to bang on this node to get its information. So we'll make a trigger bang bang here, and the first bang is going to go to the jit.anim node and first get position and get rotate XYZ, which are the two properties of the jit.anim node in which we are interested, the position and the rotation. So we'll send that to the jit.anim node, and what comes out of this outlet, the dump out, is going to be that position and rotation. So we'll route position, and rotate XYZ. I said XYZ, which is funny because I don't actually say Z, but it's fun to say. Position, rotate XYZ, and then we're going to have two packs here. Pack, set cell, 0, val, float, float, float. And these are going to be what we use to set the position and rotation of our... So we're going to hook this polycube up to a JIT GL multiple and use it to use this business here to set the individual cells. So here the position is coming out as a list of 3 things. That's going to set this inlet, and this inlet, respectively. And same goes for this rotate XYZ. A list of 3 things is going to come out along this patch cord, and because of the way inlets work, it's going to set the first one here, the second one here, and the third one here. Cool. And then we need an out 1 and an out 2. Okay, I thought Max crashed for a second. Out 2. So there's what's being sent out, the first outlet and the second outlet. Amazing. Cool. Okay, last thing we need. Each one of these is talking about an individual cell in the matrix. How does it know which cell it is? Piece of cake. We use a this poly object with a load bang. This poly will report which instance of poly it is. So the first poly will have a 1 come out this outlet. The second poly will have a 2, and so on. So all we need to do is send that to this cell of hold on. To this cell of our pack. Cool. Okay, so once again with feeling, each one of these polys is responsible for sending a set cell message to an individual matrix cell that is going to be sent to JIT GL multiple to determine the position and rotation of each square. I know, brilliant and crazy, but this is the mind of Rob Barr. It works in mysterious and beautiful ways. We can only observe it from the outside and try to make inferences from without, the mean beasts that we are. So that's all set up. A lot of very biblical tutorial. I don't know what to say about that. It's the Jerusalem. It's starting to affect my mind. Apparently there is such a thing as Jerusalem syndrome. I was looking at syndromes related to cities. There's Stockholm syndrome, Paris syndrome, Florence syndrome, I think, and Jerusalem syndrome. And they're all, sorry, I got totally, now's not the time. Can't be distracted. So let's see, this polycube thing, cool. So I'm gonna make this, leave it at 125 instances, give it target, wait, let's make sure that this is saved. It is, excellent. Give this target 0. This should rebuild much faster because it doesn't actually have any GL materials in it. So we don't need any of this. I'm just going to delete it for now. Cool, and now each one of our polys looks like this. Now, What we need next is two matrices, or rather we need a jit.gl.multiple. It's expecting three different kinds of information: the position, rotation, and color. So we'll say at gl params position, rotate xyz, and color. And then of course we hook this up to a jit.gl.grid shape. And to make the drawing a little bit more efficient, we'll explicitly say at shape cube at cull face 1, which means don't draw the faces that we can't see anyway, which saves some time. And at dim 8, 8. I think cubes are dim 20, or grid shapes are dim 20 by default, but for a cube that's redundant and just ends up wasting a lot of drawing. So now the multiple is bound to the grid shape. We can apply a material to each one of these grid shapes like so. This is going to be one material shared across all the grid shapes, which will speed up drawing. We can still, of course, set the color individually by passing a matrix to this inlet of jit.gl multiple. But we don't need to worry about that. For now, we just make a jit.matrix 3 float 32 100. Duplicate that. This one is going to be the position, and this one is going to be the rotation. And the position, each cell is of course being set by poly, both of the position matrix and the rotation matrix. The only thing we need to be sure of is that these have as many cells in them as poly has voices. So trigger, we will do a let's see, message voices, voices $1 and message dim $1. So using this integer box, we can change the dimensions of our poly, the dimensions of our matrices and the number of voices in our poly. We're interested in load mess 125. So by default, we'll have 125 voices, and our matrices will be of dimension 125, like so. Cool, we're almost there. Last thing we need to do is make sure that, as you can see, this poly needs a bang in here to report the position and rotation. So we will just do a receive pre-render that will first bang on this poly to set all the cells of the matrix, and of course we want to actually talk to every one of those polys. So instead of just sending a bang, we actually need to first set the target to 0, target 0, and then send a bang, like so. Okay, then after that we actually bang on each of these matrices to output the result. I'm turning off this metro because it's slowing down my patching. Cool, so let's see, this will set the number of saving because I don't want it to die. This will set the number of voices. Matrix, I think that's basically good. The only thing we need now is to update this noisy thing so that it actually sends. So let's see, instead of noise 1 float 32 3, we'll make a 3-plane matrix of noise with 100 here. And we want to set the dim like so that this will move all the cubes. And let's just bang this again, save really quickly. So all I'm doing now is taking that noise stuff that was inside each of our polys, and instead of sending individual noise to, instead of making the, so before we had each cube calculating its own position randomly, and in this updated version we're going to make one noisy matrix for all the cubes and set it this way. So let's see, so we'll have a bang here, a button here, and we push this button. Let's see, by default, let's have each of these cubes be scaled up by position 6 and take 1 second to get where they're going. So we push this bang. First thing we want to do is to send to the cubes message 0 target 0. This will tell all the cubes that we are... Oh, we don't actually need to do that. Screw that. Let's see. First thing we're going to do... Oops. All we need to do is calculate noise for the position of all the nodes, and then we want to animate to those positions. So this jit.noise comes out a 100-cell array of noise, each of which has 3 planes, an x, y, and z. Instead of jit.spill, we're going to use jit.iter. Jit.iter is awesome. It iterates over all the cells of the matrix. This outlet here reports the cell, and this outlet here reports the contents of that cell spread across all 3 planes. So it's basically an Uzi and a jit.spill rolled into one. I'm going to have this this output here, 0 target 1. This will set the which cube we're telling to move, and then this will actually prepend 1. This will actually move the cube to its position. So we hit this bang, it makes noise, we iterate over each cell of that noise, tell the appropriate cube that we're talking to it, and then tell the appropriate cube to move. That should all work. As long as we have this to the cubes hooked up correctly, we need to do a route 101, and this way we can talk to the first inlet of polytilde and the second inlet of polytilde. Starting to get messy. I'm going to clean this up just a little tiny bit. Move this down here. Move this like so. Cool. This is looking a bit better, but these patch cords could be cleaned up somewhat. Like this. And this. Amazing. So now if I tell this to start drawing, it's going to draw all the cubes like that. And if I push this, they should go to a noisy position. Should go to a noisy position. They're not. Why aren't they? Let's see. The Q Metro is on. It's doing its thing. Is this sending out set cell updates? It is. And these are going to random positions, presumably. Is this matrix outputting? It is. JIT multiple 3, load mess 6, load mess 1. Let's see, oh, wait a minute, this is, okay, JIT.iter goes from 0 to 100, but or 0 to 99, but our targets go from 1 up to 125, so we should have to do that. Let's see if this fixes it. No. Let's see, what's coming out of this route when I push this button? Goes targets from 1 to 125, that's right. What's coming out of here? Move to a position over the course of some time. That is going to the JIT anim drive to the right place. Which XYZ position, this poly, okay, wait, I got it. This poly, the poly instance goes between 1 and 125, but the cells of the matrix go between 0 and 124. So this should actually look like this. We should load bang this. Yes, save this, close that. And we probably need to remake this. And then hit this load mess again. Fingers crossed. It's not working. Why isn't it working? These are all being told to move to the appropriate positions. A matrix is coming out of here. JIT.iter. What does this matrix look like? Routes 3. Gate 3, 1. So whenever this is 3, what's coming out of here? Zero, zero, zero. All the cubes are being told to go to position 0, 0, 0. So maybe what's coming out of here should be set cells. Set cells 0. Oh, okay, okay, okay. Wait a minute. I got it. Set cells 0. Okay. I got it. I got it. I screwed up the set cells. Oh man. Basically, this guy should be going. Let's see. Pack set cell, and then the cell to set, and then this one should also be the cell to set. That's it. That's it. That's all I screwed up. So a lot, but also a little. Save, close. That's working a lot better. Load mess, save, push this button. Yes! Look at that! Our genius is unbounded! Bow before us, worlds of men, for we are gods. Okay, let's see. Metro 750. Throw a toggle up in that beanie. Okay, sorry, Sam, please stop talking like that. You're in public, for God's sake. You're on the internet, you're in public. Connect this to this, and now our cubes are doing their cubey. Oh my god, look at that. Ease func cubic, because if it's not cubic, it looks like poop. And we'll connect that up like so. Yes. Yes. Yes, look at it! It's beautiful! And not working anymore. Why did it stop working? Oh, come on, that's not funny. No, oh, what are you talking, what, I don't know how to handle this. Somehow just making it full screen broke it. And now unmaking it full screen unbroke it? If I make it full screen again, does it break again? Yo, that's not funny. Oh, because it changed the graphics context? And this is saying bad, who's got a bad number? Oh god, I broke Max. Oh god. Oh no. It's over. Oh man, okay, force quit Max. Let's open it back up. Save and go full screen. It stops working. Okay, well I don't know why it stops working when it goes full screen. I assume it has something to do with the, I don't know, I'll have to, look into that. I don't know why that's happening. In any case, you know, there you have it. That's kind of amazing. A really tremendous work. Huge, obviously, massive thanks to Rob R for showing me how to do that. It's just really, really cool. We can also, like, this color thing is redundant at this point. It doesn't actually work, but in a similar way, if you just copy this Metro, you know, noise, you can use this to make random colors as well. Let's see if we hook this up to the color. I promise we get random colors, and so let's get some random colors, right? Save it, and there you can see random colors. And of course, the stupid. I don't know why the going full screen breaks it. As always, thanks for watching, guys. More cool stuff to come. Stay tuned, and I will talk to you very soon. Auf Wiedersehen.